Let's get started. I would like to introduce Kaizen's own Ram Wissel.
Hi, Chelsea. Thank you very much. And this is going to be a fun topic. There's a lot of information to cover tonight or this morning, and so thank you for joining. Today's topic is which cleaning process is right for cleaning your PCBAs, inline or batch. And so we want to start this with looking at some inline cleaning machines. And you can see in the picture here, there's a very diverse array. Some machines are made out of polypropylene, some are stainless, some are longer, some are shorter. But if you look at it, there's some commonality really to the design. And some of those highlights that we're going to touch on briefly is they have an open tunnel conveyorized design. So there's a conveyor belt. It might be 18 or 20 or 24 inches wide that runs the full length of the machine. It has large pumps, sometimes 80 to 100 gallons or up to almost 400 liters, powerful pumps, and a lot of different nozzle configurations. And if you look through the diagram here, it's kind of like an inline or an automated car wash where you go through a wash cycle, a chemical isolation or a coarse rinse, and then a main rinse, final rinse, and then kind of your dry. So it's just this continuous conveyorized process. And what that allows is it allows for maximum throughput production capacity. But with that, there's also some potential negatives with drag out potential and exhaust losses. So let's take a look at that. And what we have is that inline cleaning operation tends to be very dynamic. I like the image here of the bucket with water and chemistry pulling in or pouring in, but there's also a couple loss paths coming out the bottom of the bucket. And you have wash pump operation, the product volume, how much product are you washing? Are they in baskets? And that conveyor belt operation, it's always moving. And so we consider those things drag out or horizontal losses. But also in that exhaust, you also have in that inline diagram some exhaust losses, things that go vertically due to evaporation in that open tunnel design. Because you want some exhaust so that you don't have steam pulling out or pouring out the vapors pouring out the ends of the machine. And so typically, an inline cleaner can use up to 8 to 10 gallons of total wash solution per hour. And that's significantly more water than chemistry because water evaporates faster. So it's about 10 to 1. So if we look at this, I like this chart because you start out in this blue line here, time zero at 15%, and the red line here starts out at about 80 gallons in your tank. After just 2 hours, you could be approaching 16.5, 17% of concentration if it's just due to water evaporation at that temperature and that open exhaust design. And then your tank volume could go from about 80 down to about 65 gallons. And so it takes some operator attention and makeup and replenishment. So if we change and say, well, what about these batch wash systems? And just like the inline, they come in a lot of sizes and shapes and colors. But what we're going to focus on today is really sort of the dishwasher style. It's the most popular design. And you can see in the picture here on the right-hand side, it kind of looks like the inside of a stainless steel dishwasher with the rotating spray wand at the top and a basket. And some of them may have 2 or 3 baskets, and we can talk about that. And there's some innovative spray designs and things that different manufacturers have done. But in general, what's attractive about the batch design is it has a smaller footprint, smaller tanks, and it's a sealed chamber design. When you close that door, there's a gasket around it. It's not like the open tunnel, so there's practically no exhaust. And so with that, you have reduced chemical, water, and energy use. So capacity and throughput on it tends to be based on the chamber size and the number of racks. How many boards can you put in a batch at a certain time? And then there's some potential for lower fluid energy at the board surface, or in the corner of the chamber, maybe there's a little bit less exposure. And let's look at that as we look at the typical behavior and kind of compare it with the inline. We've looked at several different machine types and done studies where you start out at 15%, and let's just run them for 5, 10, 15, 20 cycles. And what you see in this chart is that they all stay relatively constant in concentration. You lose some material, but unlike the inline, that concentration stays really consistent. So that's an advantage, right? And then it's more like that sealed keg or bung that doesn't really change. It's a nice, happy thing. So if we come back and look at the spray dynamics a bit, And you're looking in this left-hand side here, you can see a kind of a top-down view of the basket with the spray bar. And as it rotates, it's kind of like a round peg in a square hole. Right under the center, you get a lot of really good exposure and wetting, but in those corners, you may not get quite as much out at the edges. And so some manufacturers have done a nice job creating mechanisms to shift the basket or work on ways to eliminate some of that shadowing, which is really good. And if we change and look at the inline, kind of that conveyorized process here, what you see here is the array of boards. They just continuously move along the path of the conveyor. But again, there's some differences in nozzles and technology that are used, and maybe some different angles so that you block or you compensate for some of the shadowing. And so when we talk about that, is shadowing, is device orientation important? And I like this picture because you've got some connectors and an LED screen and some collar components. But right here in the middle, you see some small little chip caps and other components. And if I wanted to clean those, that might be kind of complicated. So if I've got the board horizontal and your spray nozzles are at the top, gravity and pooling kind of can assist cleaning in some of those hard to reach locations. If I rotate that board and it's on its edge, now that spray is coming down through that terminal connector there on the top, and it's a little bit harder to get those small little devices right in the middle of the board. So tilting on the edge maximizes your available space, but it eliminates that gravity and pooling effect. So it's great for storage, but it can create some challenges in shadowing for some of the more complex designs. Let's talk a little bit here about batch volume and the potential for capacity. We think about normally with, say, maybe it's a 10 or 15-minute wash cycle. That sounds really short, but there's also drain time between the wash and the rinse, maybe 5 minutes, 10 minutes or so for rinsing and then drying, and then some miscellaneous time for opening and closing the doors and whatnot. So that 10 to 15-minute cycle can easily approach 45 minutes to 60 minutes. So let's just, for the sake of this example, look at a 48-minute cycle time. Now, if I'm thinking about production, I've got an 8-hour shift. Really, that works out to be a little bit less than that, maybe just a little under 7.5 hours when I have, or a quarter when you have lunch and breaks and so forth. So, if I take that 7.5 hours or 7.25 hours and look at that 48-minute cycle, I can probably get about 9 cycles in a shift. And again, this is just showing some of the math and thoughts of going through how you would calculate this. So now I want to look at my basket size. And let's say I've got a 20 by 20 inch basket and I've got some 10 by 10 inch boards. Well, I can probably fit about 12 in a single rack per cycle, which means in a given shift or single operating shift, I can clean maybe 108. And so there's a lot of information here. This is being recorded, like Chelsea said. So, if you have questions at the end, we can come back, or you can pause and rewind. But the idea is just in this short little snippet to share some thought process on how you would determine capacity and what you might need to do if you're looking at a batch washer so you properly size it for your operation. So really, which is best for me? And it really depends. There is no universal optimum or best answer. But things you want to consider are really the size of the boards that will fit in a chamber. And as a contract manufacturer, you probably have an array of different board sizes and shapes. And so you're going to need to just look at all of those combined together. How many shifts of operation do you have? Is it 1, maybe 2 or 3? What's the capital budget for the machine? How much floor space is available? The need for flexibility in changing products or concentrations possibly, or multi-chamber machines, or putting machines in different areas of your operation, of your facility. So if I come back and look at some of the things, just kind of in summary, footprint, the batch washers tend to be a bit smaller. Inlines tend to be medium or large. There are some smaller ones, but in general, they're 15 to 25 feet long or so. Relative cost, with that smaller size, the batch washers cost a little bit less, and they can be pretty expensive if you have a large stainless steel inline cleaner that's 25 or 30 feet long. Again, we talked a little bit about throughput capacity. That conveyorized process is really efficient and helpful. The batch washers are a little bit smaller. It's really based on the number of racks and the chamber size. And when we think about chemical and water usage, that smaller sealed chamber size with very little exhaust is really helpful versus the open tunnel design that has a little bit more consumption on a regular operator ongoing basis. And then right in hand with that is sort of the operator intention. If you've got that inline washer, you're going to have to be measuring the concentration on a regular basis. And you may also have an operator at each end of the cleaner loading or unloading the board. So it's routine. Whereas in the batch washer, normally it's a bit more minimal where you close the door, set the recipe, and come back in 45 minutes or an hour. Overall flexibility, they're both good, but because of that smaller chamber size and tank size, it's a little bit easier to adjust concentration or your recipe in that batch washer. But again, if we're cleaning those complex PCBA assemblies, they can be challenging in the batch washer because of the angles. You can certainly lay them flat at the bottom of the belt or at the bottom of the basket, but that affects your capacity as well. So we say that we think about the inline cleaners with that perpendicular flow and different nozzles being most effective for that. So it's really just kind of a balance of deciding what's the most important for your process, the boards you're cleaning, and your budget and footprint. So with that, I appreciate time's gone really fast here. Chelsea, what questions do we have?
All right, thanks, Ram. If you would like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.
Thank you.